Hello everyone, in this video we are going to talk about how we can write some transformations of radical functions. So in previous videos we've talked about how to actually graph these transformations and identify them and perform them on a graph. And so now we're going to see, okay, there's no graphs, we're just going to take an equation or a function and we're going to say, okay, we're going to do these two transformations to it or these three transformations, and so how would the equation actually change? And so we're going to do three examples in this video. The first one says, let the graph of g be a horizontal stretch by a factor of 3, followed by a translation 6 units to the right of the graph of f of x equals the cube root of x, and then write a rule for g. So we're going to do a horizontal stretch by a factor of 3, and then a translation 6 units to the right. And we're starting with the cube root of x as our function, okay? So we're going to end up with g of x, but before I get to g of x, I'm going to perform just one transformation at a time. So I'm going to say h of x would be equal to, and this is going to be my horizontal stretch by a factor of 3. So we got to remember what the notation looks like for a horizontal stretch. We know that we're going to be multiplying here because it's a stretch or a shrink. And so it's horizontal, so we should be multiplying x. And so now we should say the f of something times x. Now, should it be 3x? Well, remember, horizontal stretch and shrink is kind of opposite of what it looks like because we stretch or shrink by a factor of not a, but 1 over a. So if it's a stretch by a factor of 3, in order for us to say that, it had to look like f of 1/3 x. Okay, so now if we see that, we would say, oh, okay, horizontal stretch by a factor of 3. So now let's input our f of x function. So f of x was the cube root of x. So now this is going to be the cube root of not x, but 1/3 x, right? So now h of x is equal to the cube root of 1/3 x. So this is us applying the horizontal stretch by a factor of 3. Okay, now we can do our translation 6 units to the right. Well, translation 6 units to the right, we will come over here and say, okay, now g of x should be h of x. Now, translation, adding or subtracting, horizontal, so because we're going to the left or to the right, we're going to the right here, we need to add or subtract 2x, right? So it should be the h of x plus or minus 6. Well, if we're going to the right, it's going to be minus 6. Okay, so it's going to look just like that. So now what we're going to do with this x minus 6 is we're going to replace this x in our h of x function. So now we have g of x is equal to the cube root of 1/3 times x minus 6. And now we can distribute that 1/3 to simplify and get our final rule. So g of x is equal to the cube root of 1/3 x minus 2, right? Because 1/3 times 6 would be 2. So that would be our final rule for g. All right, number 2 says, let the graph of g be a vertical stretch by a factor of 2, followed by a translation 2 units up of the graph of f of x equals the square root of x plus 3. And then once again, write a rule for g. So first thing we're going to do is our vertical stretch by a factor of 2. So once again, I'm going to say h of x is equal to, and now this time we have vertical stretch. So we're not multiplying x, we're multiplying f of x. So we could say 2 times the f of x. And now we know f of x is the square root of x plus 3. So now we could say h of x is equal to 2 times the square root of x plus 3. Now we can distribute that 2 to simplify that a little bit. So we get 2 root x plus 6. Now our next transformation is a translation 2 units up. So now we could say g of x is equal to h of x plus 2, right? Because that's what a vertical translation up would look like. So now we can write g of x is equal to, this is our most simplified h of x equation or function or expression. So 2 root x plus 6, and then we have this plus 2 at the end. So now to simplify, to find our final rule for g, we can just combine like terms and do 6 plus 2, not 2 root 6 there, 2 root x, to get our final rule for g. So g of x is equal to 2 times the square root of x plus 8. And our last example, it says, let the graph of g be a translation 1 unit down and 5 units right, followed by a reflection in the x-axis of the graph of f of x equals negative 1/2 times the cube root of x plus 4, and then write a rule for g. So we actually have 3 transformations here. Translation 1 unit down, 5 units right, reflection in the x-axis. So I'm going to kind of do just one at a time. So let's start with h of x again. And we're going to go 1 unit down. So this is just going to be f of x minus 1, okay? So now we can say h of x is equal to, and we have negative 1/2 times the cube root of x plus 4, and then minus 1 at the end. So now once we simplify that, we'll have negative 1/2 times the cube root of x, and then plus 4 minus 1 would be plus 3. Okay, so that was our transformation 1 unit down. Now for 5 units right, let's say maybe t of x, and that's going to be 5 units right, so that's going to be the h of x minus 5, right? Because we're going 5 units to the right, okay? So now we're going to take our minus 5, x minus 5, and replace our x under our radical. So we can say t of x is equal to negative 1/2 times the cube root of x minus 5, and then we have the plus 3 on the outside now. And our last thing we need to do is our reflection in the x-axis. So we'll get back to g of x here finally. And so g of x is just the opposite of t of x. So we could say g of x is equal to the opposite of negative 1/2 times the cube root of x minus 5 plus 3. So our final rule for g would be g of x equals, we're going to distribute this negative, so that would be 1/2 times the cube root of x minus 5, and then minus 3, okay? And that would be our final rule for g, and that is how we can write some transformations of radical functions.